Okay, let's talk about today's project. It's rather the month's project. So, this is my little portable radio, puts out 5 watts. It has a built-in keyer for Morse code, but it has no memories. And I got kind of tired of building little external keyers with cute little built-in memories, 10 memories, 20 memories. I said, that's crazy. I've got a smartphone. Why don't I turn my smartphone into a keyer with infinite numbers of memories and messages that it can play? The question is, how do you get the sound coming out of a smartphone into something that can trigger the radio's keyer? So if you look at the back of the radio here, it's got a little jack for a keyer. And the theory is that it sends out a small current out that jack, and it looks to see if you're pushing down on your straight key or not, right? And if the circuit's closed, then it thinks, okay, I'm going to make a beep. So the question is, I want to figure out a way for my phone to make beeps and have this thing think that I'm closing the circuit. So I presented this problem to my buddy, my Elmer, Jack AI4SV, who's a great at double E stuff, and I am quite the novice. And he designed a circuit, which you can see over here. I'll put it up on the website at the top there, which is a simple circuit. Essentially, what it does is it takes here's my smartphone, takes the audio output of the smartphone, and runs it into a transformer. Transformer converts the output from about half a volt into about 5 volts, about a 10-fold increase in voltage. From there, it goes into a full wave rectifier, converts AC into DC, and then it goes through a couple other little things, capacitor, a couple of resistors, and it goes essentially into a transistor, an NPN bipolar transistor, and it sends a current into the base, and that causes the transistor to close like a switch, which triggers the keying circuit on the radio. Now, I don't actually have the radio hooked up here. Instead of a radio, what I've got here is a simple this little board here. Just has a cute little diode on it, little LED that lights up in place of the radio. And so I'm treating this whole board like a giant switch. Basically, it is either the transistor is letting the current go through or it's not. And if it lets the current go through, then this guy lights up the diode. So it's all hooked up. This is interesting to me because this is the first time ever as an electronics newbie where I actually had to convert, I don't know if you can see this, but I actually had to convert the schematic into a breadboard. I've done breadboards before, but only just, other people's designs. I've never had to figure it out myself, so it was a lot of fun. So meanwhile, that's the hardware part of the project. The software part is we actually got to write a simple Android app, which is a keyer app. I don't know if you can see it here. Yeah, there we go. You can see you can type anything you want in the little area here, set the speed, set the tone, and when you click start, it just starts playing Morse code out the jack. Now watch, when I start the CQ going here, you can see the LED. Here's CQ. AI4SV. Pretty cool, huh? Turning sound into light, or in this case, sound from the phone closing a circuit over here, which of course we can easily use to close the circuit on the radio eventually. That's the next step. So yeah, this is exciting for me because this is my first time actually combining software and hardware. First time building a breadboard from somebody else's circuit design, trying to figure out how to breadboard it. And when I'm done, hopefully we'll have something that fits in an Altoids tin that will be a bridge between my smartphone keyer and my portable radio. Thanks for listening.